Alright, so we've been talking about for a while now is how to differentiate functions, how to take the derivatives of those. And so far everything has been y in terms of x. So it's like y equals this, y equals that. But now what we're going to do is we want to look at there's going to be times when functions are determined by an equation where it's y to the fourth plus x times y equals x cubed minus x plus 2. And so what we say there is that y is defined implicitly. Alright, so it's not clearly stated what y is equal to. And it may be impossible to always solve explicitly as a function of x, but what we can do is we can still find the derivative using what's called implicit differentiation. And what I mean by it may be impossible to solve explicitly as a function of x is this function right here is not possible. It would not be possible for us to get y by itself and say y equals something. Okay? So when that happens, we're going to have to use what we call implicit differentiation. And what implicit differentiation is you're going to take the derivative of both sides of the equation with respect to x. Should have written that down. But, so what this means is that we're going to treat x as an independent variable, and we're going to treat y as a separate function, almost in a sense of like it's an f of x. Alright, so what we're going to have x, which is the independent variable. We're going to have y in it as well, now, which is a function within a function. Okay? And what you're going to want to do is you want to think, when you see these y's in the function, you want to think changeable. Okay? So what we're going to do is we're going to treat the y's in the equations, in the functions, as separate functions. So you have a function within a function. And when you have functions within functions, you use change. Okay? So, what I want to do is I want to start off by looking at this function. Right. X squared plus y squared equals 1. Alright. And just like for now, it's okay. You guys know what this is the equation of. What is this function? Oh, it is a circle with a radius of 1. Okay. So we have a couple. So how might you think we could go about finding the derivative of this? Could we get y by itself in this case? So how could we get y by itself here? We just subtract x squared from both sides. We get y squared equals 1 minus x squared. And what? Take the square root. And we get y is equal to, now it's not just the square root, there's 1 minus x squared, it's going to be like plus 4 minus, positive 4 negative square root of 1 minus x squared. Alright? And then we get into an issue here. Alright? We have two different functions that we have to figure out the derivative of. Alright? And we know that this function is this equation is the equation of a line or a circle with a radius of 1. And what we would now need to do is we would have to know what part of the circle are we dealing with when taking the derivative? Alright? So there's not just one derivative for this function. There's two different derivatives, and it depends on which part of the circle are we on. Are we on the bottom half or are we on the top half? Okay? So that would start getting really tricky. So what we can do is we can go back and we can use differentiation. Alright? And if you think of this as chain rule, and if you put parentheses, it might be beneficial for you right now to put parentheses around the y's. Alright? Put parentheses on the y. So what we're going to do is we're going to take the derivative of each piece of it. Alright? So what is the derivative of x squared? Okay. Now, remember what we said, think chain rule here. Right? Y is its own function. So, what would be the derivative of 2y? Well, you bring the 2 down, so you have plus 2, and you chain rule, you take the derivative of the outside first. So you take the derivative of the outside, so 2, and then we have a y. Subtract 1 from the exponent, it's just 1. Times the derivative of the inside of x. What's the derivative of y? Y is a function. So think of y in terms of a function. So the derivative of f of x would be y. Okay, so it would be y prime, or we're going to tend to write it dy dx. All right. Already, now remember, it's the same way. What is the derivative of y? Well, it's dy dx equals this. Alright, so that's the derivative of this right here. Y squared is the derivative of that 2y times dy dx. Alright, now you have to take the derivative of one side, you have to take the derivative of the other side. So what's the derivative of y? 0. So what are we trying to find? We're trying to find the derivative of y. Okay? So we're trying to find what dy dx is equal to. Well, how can we solve for dy dx? How can we figure out what dy dx is equal to?
Put it on one side.
Get dy dx on one side all by itself. Okay, so what's the first thing I'm going to do here?
Divide
Divide by dy dx? Now, I'm just going to show you what happens if we divide by dy dx. We divide by dy dx, we divide the entire thing by dy dx. So I'm going to divide that by dy dx, I have to divide that by dy dx, and I'm going to divide this by dy dx. What's going to happen is I'm going to have a dy dx in the denominator. That's no good. Okay? That's making it more complicated. Okay? Let's subtract 2x. That leaves us with 2y is equal to 30. No, not 2y. 2y times dy dx is equal to negative 2x. Alright. Good. Michelle, what can we do to get dy dx? What would be the next thing we want to do to get dy dx by itself? By what? Let's divide by 2y. That's going to cancel that out. We divide by 2y over here. So we get dy dx is equal to negative 2x divided by 2y. Negative 2 divided by 2, the 2's cancel out there. Negative x divided by y. And that is my derivative. Now, up to this point, we've only had one variable in our derivative. Right? It's always been dy dx is equal to, and it's like x, something x, something x. It's always x, it's always one variable. Okay. Well, in this case, we now have two variables, x and y. And a lot of times, what the question is going to be is, well, what is the slope at of the tangent line at a point. And when you're using implicit differentiation, what the problem has to do is the problem has to give you an x coordinate and a y coordinate. Because if we look at this, all right, and let's choose one of these. Which one of these equations do you guys want to find the slope? Which point? This point? All right. So let's find the slope of the tangent line at that point. All right. So typically, what we would do is we have our derivative when we plug in x, right? And you solve, you get dy dx is equal to whatever point is. Now that they only give you 1 point. Now what's the issue here? If we're looking at what's the x value that we're looking at? 3/5. Okay. Well, this is a circle, correct? So there's this point that is at the x value on 3/5. Then there's also this point where the x value is 3/5. So what has to happen, the problem has to tell you which one we're working with, because that tangent line is much different than that tangent line. It says a negative slope and has a positive slope. So what you have to know is, if you have the x value, you have to be given the y value. So let's find the slope of the tangent line. So you have dy dx is equal to negative x. So the opposite of x, which is opposite of 3/5, is negative 3/5, divided by y, which is 4/5. Alright, so that's going to be equal to, you don't know what that's going to be equal to on top of that? So negative 3/5 divided by 4/5 is equal to negative 3/5 times 5/4. 5 is cancelled out, it's equal to negative 3. So what we figured out is that the slope of the tangent line at this point, 3/5, 4/5, is equal to negative 3/5. Questions about that? Now this is a relatively straightforward problem. And so a lot of times what you're going to see is problems that look like this. Alright? And you're not going to freak out about it. You're going to take them piece by piece. Chain rule by chain rule. And you're not going to lose sight of the fact that it could be product rule or quotient rule at times. So what we want to do is we want to find the slope of the curve at the point 1, 2. Notice it tells us point 1, 2. Notice the x and y value of the point that we're looking at. So we have y to the 4th minus 4xy equals x cubed plus y plus 5. So, again, what we're going to do is we're going to start piece by piece and take the derivative of each term. So, what is the derivative of y to the 4th?
4y.
Alright. Is that it?
Yeah, yes, the y.
So the y is in parentheses, so if you go 4y cubed, you have to take the derivative of the inside of the parentheses, which is the derivative of y, and the derivative of y is equal to what? dy dx. So it's going to be derivative of the outside times the derivative of the inside. We have minus 4xy. Now here we have the product rule. Alright? Can't lose sight of the fact that the product rule is still out. Okay? So you have minus, and then we have our u, which is 4x, our y, or v, which is y. So it's going to be u dv, so u dv, what's the derivative of y?
dy dx.
dy dx. Plus v times du. The derivative of u would be what? 4. Okay, good. We'll come back and simplify that later. You're taking, so that's the derivative of the left-hand side. We need to take the derivative of the right side. Okay, so the derivative of x cubed, here will be what? 3x squared. Cool. And then we have the derivative of y shamar will be what? dy dx. Okay, and then Michelle, the derivative of 5 is 0. Alright, so let's go ahead and make this all look a little bit nicer without the parentheses. So we have 4y cubed times dy dx minus 4x dy dx, and then minus 4y, which is equal to 3x squared plus dy dx. Alright, now we're trying to find the derivative of the slope. We're trying to find the first derivative, correct?
That one's minus 4,
There's a minus another, yes. So we need to go ahead and I don't know, we're trying to solve for our variable dy dx, right? So I'm thinking that we probably want to get all the dy dx's on the same side. So if you look at this, let's go ahead. This does not have a dy dx. I want to get that over to the other side. Let's go ahead and add 4y there, and we're going to add 4y over here. I also noticed that I have this dy dx here. I want to take that and subtract it to the other side. Alright, so what do I have? I have 4y cubed times dy dx minus 4x times dy dx minus dy dx. That's equal to 3x squared plus 4y. Okay. Well, I have dy dx in 3 different terms. Correct? So, what can I do with that dy dx in those 3 terms? If I have the same variable in 3 different terms, what can I do with that variable? Not combine them. They're kind of combined. I can't really combine these because this is 4y cubed and that's 4x. What can I do with this dy dx, this dy dx, and this dy dx? I don't know, you tell me, because they have, all 3 of these terms have something in common. What do I do when I have something in common from 3 different terms? That's called what? What's the mathematical term for taking something out of 3 different terms? Yeah, don't answer that. So, we're going to factor in dy dx out of all these. Take the dy dx out of 4y cubed, and let's do 4y cubed. Take the dy dx out of negative 4x dy, I'm left with negative 4x. Take the dy out of negative dy dx, and left with negative 1. It's equal to 3x squared plus 4y. Okay, so I'm going to get dy dx all by itself by dividing. 4y cubed minus 4x minus 1 on both sides. 4y cubed minus 4x minus 1. So I get a derivative dy dx is equal to 3x squared plus 4y divided by 4y cubed minus 4x minus 1. Okay. So the question was asking, what is the slope at the point, I believe, 1, 2. Okay, so how do I find that slope? Well, I'm going to plug 1 in for x, 2 in for y. So I'm going to have 3 times 1 squared. 1 squared is going to be 1 times 3 is 3. Plus 4 times 2. Well, 4 times 2 is 8. Divided by. 4 times, okay, so 2 is going to be 2 cubed, that's 8, 32. So 8 times 4 is 32. Minus 8 minus 1 is equal to 11 divided by 32 minus 8 is 24. 23. Another 23. Okay. Oh, error. That's negative 4 times 1 is negative 4. So it's going to be 27. We have 11 over 27. So that tells us that the slope of that graph is 11 over 27. All right. Now, here's it. We don't know what that. We don't know how to graph that on our graphing calculator. All right. You would have been able to figure that out by using math aiding. But using implicit differentiation, we were able to figure out that the graph had a slope of 11 over 27 at the point 1, 2. I think we got a graph up here on the actual equation there. So that equation right there gives us that graph. Okay, not a function. And we see right here at point 1, 2, it has a positive slope, which is good because we got a positive slope. All right. Questions about that? Now we want to find the derivative of x squared minus cotangent of x divided by y equals. So, how do we start here? Find the derivative. Okay, so we're finding the derivative of each term. So the derivative of x squared is going to be what? 2x. Then we have minus cotangent of x divided by y. So what, first let's think about what rules this has. Not product. Quotient rule and then chain. So it's the quotient rule inside the chain rule. So how do you find the derivative of that? Well, chain rule you start with the outside and you work your way up, right? So we just find the derivative of this cotangent piece first. So we know what the derivative of cotangent is. negative cosecant squared. So we're going to have minus, actually, it's going to be minus negative cosecant. So it's going to be plus cosecant squared x divided by y. Alright. Now, Shamari says the quotient rule is on the inside, correct? So, this is going to be our u, this is going to be our v, this is going to be times, alright? Well, we know on the bottom we're going to have y squared. So it's going to be y. So v times the derivative of u, which is the derivative of u is what? 1. So y times 1 minus u times dv. The derivative of y is what? dy dx. Okay. And that's equal to, what's the do? And a lot of times people are going to do, and I don't want you guys to do this, is they forget to take the derivative of the constant on the other side. So what is the derivative of 4? 0. Alright, so now my goal, my job is to now do what? To get dy dx by itself. Alright, I want to find out what dy dx is. Nice thing is, we only want dy dx. Alright, so what's the first thing that you guys are doing to get dy dx all by itself so you can figure out what the derivative is? Yeah, good. Can't do that yet. Move anything over to the other side yet. You got 2x over there. Yeah. So, let's subtract 2x. Subtract 2x. So we get cosecant squared x divided by y times y minus x dy dx divided by y. That's equal to negative. Alright. What would you guys like to do next? You tell me what you would like to do, I'll tell you if you're out. Does have to do with cosecant.
I would like to know like that whole
Cosecant thing?
with the x, y.
This?
Yeah.
Yeah, you can do that whole, that's all one term. How do you want me to move it? We're going to divide by cosecant squared of x divided by y on both sides. Alright. So, at this point, we have y minus x times dy dx divided by y squared. That whole thing is equal to negative 2x times, or divided by cosecant squared divided by y. And next thing that we would like to do is here, you tell me what you want to do, I tell you if you're allowed to. Huh?
Can we factor a y out of here?
Factor y out where? This side? No, there's no y in this term. I can do something with y over here. Someone help her out.
Okay, you want to take away that first one?
This one?
You want to move that, or you want to move the bottom?
I would like to eventually do this one, but I can't because then so that tells you the answer to your question.
So we're going to multiply
Multiply both sides by That's so that left with y minus x times dy dx. And that's equal to negative 2xy squared divided by cosecant squared. Alright. Now, check y, x times d, or negative x times dy dx equals negative 2xy squared divided by cosecant squared x divided by y minus y. Alright? Can we do something real quick to make our lives a little bit easier here? So what we have right now is we have 1 divided by, not 1 divided, we do have 1 over cosecant squared x over y. Alright? We know something, we can rewrite this somehow. Just because I can have that times 1 over cosecant squared x y. If I have 1 over cosecant squared x y, what's another way I can write that?
Wait, hold on, isn't it cosecant?
Nothing on derivatives here. What is, what is cosecant equal to? Like in terms of, is it, in terms of like sine and cosine? Cosecant is equal to 1 over 1. 1 over sine. So 1 over cosecant would be equal to sine. So 1 over cosecant squared would be equal to sine squared of xy. Alright. So let's rewrite this real quick. We can make our lives a little easier. And it looks nice to do all this fraction. So negative x times dy dx, that's equal to negative 2xy squared times sine squared x divided by y minus y. Get it? Now, we have one last thing we need to do here. Get rid of this negative x, because we have by dividing by negative x. That leaves us with dy dx is equal to negative 2xy squared sine squared xy, or x divided by y, minus y, all divided by negative x. That is down. Questions about that? How is this differentiation?
I don't know if this problem is good.
Typically, the ones that you would see on AP test would be we might have a lot, you have something like that, and like something like this. So in this case, we're actually being asked to find the second derivative. So in this case, we want to find the second derivative of this. So in order to find the second derivative, we have to find the first derivative. All right, now, nice thing about this is the y and x's are already separated. All right, so let's start by finding the first derivative. So how do you go about finding the first derivative here?
Are we coming in negative?
So you tell me, Jason, what's the derivative of the left-hand side?
2y times y dx.
Now, what would be the derivative of the right-hand side? Okay. Now, I don't want 2y times dy dx or dy dx, I just want dy dx. So what would I do to get dy dx all by itself? Y dy dx equal to, these twos all cancel out, so it's x plus 1. That's dy dx. I'm going to circle that just so I know where it's on. Now, we don't want dy dx, we want the second derivative of dy, we want the derivative of dy dx. Alright? So, we have to take this, take the derivative of both sides. So what's the derivative of dy dx?
2y.
The second derivative, dy dx is the second derivative dy. The 2y divided by dx is equal to, we're going to take the derivative of this side, x plus 1 times or divided by u. What rule is that? Quotient rule. So, the first thing I know is, for sure, it's going to be divided by y squared. Because it's doesn't do the square root of 1. So, the numerator is going to be v times du, which is 1, minus u times dv, which is dy dx. Alright. Well, you guys see anything that might pose some problems right now before we do something? No, the y squared is cool. You see anything we get substitute in? You see anything that we can substitute into basically this derivative right here? What? This? What do you know about it? You know dy dx is equal to x plus 1 divided by y. So, we have is equal to y times 1 is just y, minus, we have x plus 1, times, we're going to have x plus 1 over y, divided by y squared. Okay. So let's see what we can do here to simplify that. That's going to be y minus, that's going to be x plus 1 squared, so it's going to be squared divided by y, divided by y squared. We could we can simplify this sum, we can make it look nice, so you don't have this fraction of in a fraction. We can do that. We can do that by, we can't combine this y and this right here because they don't have the same denominator. I can make them have the same denominator by multiplying that, by multiplying this y by y over y. That's going to give me y squared minus x plus 1 squared divided by y divided by y squared is equal to y squared minus x plus 1 squared divided by y. So the second derivative is that right there.
You have to, you only does that.
Anything goes. What I found right here. Did it ask you to find what the slope was? You don't have to go all the way down there. It'll tell you the x and y coordinates, so you just plug it in. And you plug in the y's and the x's, and then just figure out what it is. Alright. So I want to find the equations of the tangent lines and the normal lines to the curve x squared times cosine squared y minus sine y equals 0 at 0, pi. So if I'm asking you guys to find the tangent and normal lines, we know the point is 0, pi. What does that tell us that we need to find out?
So what about this? Wait, no.
The derivative, because we need to find the slopes. So here we go. Finding the derivative of this. So we have two parts. We have this part, which is going to be product rule and chain rule. We have this part over here, which is also chain rule. There's the y is another function. So let's look at this. The derivative of x squared times cosine squared y. So it's going to be u, which is x squared, times dv. So this is going to be, so we start from the outside. 2 cosine y times the derivative of cosine y would be what? Negative sine, so negative sine y times the derivative of y. What is the derivative of y? Huh? Yes. Alright. Then, add to that, v du. So cosine squared y times the derivative of v, which is v2x. Alright. That's that part. Take care of that first term. And we look at minus sine y. So it's going to be minus. What is the derivative of sine y? Cosine y. Now what's the derivative of y? Times dy dx. It's going to be all equal to 0 because the derivative of 0 is 0. So we just have about a simplifying to do. I'm getting dy dx all by itself. So let's see. We have, I'm going to bring this minus sign all the way out front, this 2 all the way out front. So it's minus 2x squared cosine y times sine y times dy dx plus 2x cosine squared y minus cosine y dy dx all equal to 0. Alright, well, this big long thing has dy dx in it. This thing has dy dx in it. This is the only thing right here that does not have dy dx in it. So at this point, I'm taking this piece and I'm doing what with it? I'm moving it to the other side. So I'm going to subtract 2x cosine squared of y on both sides. Alright, so that's equal to, that needs, we're leaving with. Can we combine, can we add a second step in here? This term right here has a dy dx in it. This term has a dy dx in it. What can I do with the dy dx? Factor it out. I'm going to factor dy dx out. So I factor dy dx out. That goes away. I'm left with negative 2x squared times cosine y times sine y minus cosine y. That's equal to minus 2x cosine squared y. Alright. So, at this point, I'm going to do what right here? Yep. So dividing both sides by all that negative 2x squared cosine y sine y minus cosine y. All right. So yeah, you're gonna have dy dx. Yeah, dy dx is equal to negative 2x cosine squared y divided by negative 2x squared times cosine y times sine y minus cosine y. Alright. So that's the derivative. The hard part here is the derivative.
Now plug in your step.
So now we're going to have to plug in our x's and y's to find out our slope for our tangent and normal lines. So the point is 0 pi. Alright, so we have 0 pi. So we're going to have negative 2 times 0. So that's going to be 0 times something is going to be what? 0. Over. We have, this is going to be 0 times all that, that's going to be 0. Minus cosine of pi. Cosine of pi is negative 1, so minus negative 1 is positive 1. Oh, cool, so you're telling me my slope is 0? Neat. So my slope is going to be 0. That's my tangent line, tangent slope. The nice thing is the reciprocal, the opposite reciprocal of 0 is 0. So the slope of the normal line is also, I don't know, I just feel like it shouldn't turn out to be 0.
I'm like, right, I just feel very good, well, no, I understand it on the slope of the arrow.
UDV, equals in y, minus u sine y, times dy dx, plus cosine squared y, 2x, minus cosine y, dy dx.
How you thinking of 0? I'm gonna tell you, what am I supposed to do 0?
Alright, well, let's just go over it. Tangent slope. Now, the reciprocal of that would be 1 over 0, which is not, which is undefined. So I misspoke. Alright, misspoke. Tangent of, the slope of the tangent line is 0. The slope of the normal line would be undefined, because it's 1 divided by 0. Okay. So, the equation of the tangent line would be y minus pi equals 0 times x minus 0, which is just due to y equals pi. That's our tangent line, and our normal line does not exist because it does not have a slope. So it's undefined.
We're gonna have to put the equation for the one, we can't make it. So, the line is gonna be, the normal line is
Opposite is it would be negative 1 divided by 0, which is undefined. Alright?
so like that.
And that is the end of the notes for implicit differentiation.
Yes.
But I would like to do the next set of notes. What if I told you to do it easy? What if I told you I meant it? Alright, so think about what we, so questions about that now, good? You got homework on that? Alright, so. Okay, well, here's the thing. I'm gonna skip through this, and I think if I just tell you what it is, and just tell you what you need to know, you're good. You're not gonna go through all of this. Alright? So, what I want you to just write down that red word real quick. There's black on. Is that red or black? Red or black. So, the derivatives of exponential and logarithmic functions. I know, it's really easy, yo. Alright, so here's the thing. We learned how to take the derivatives of polynomials, we learned how to take the derivatives of rational functions, we got proportional rule. We learned how to, we know the derivatives of the trig functions. So there's really only a few more things we need to know. Exponential and logarithmic being two of them. Okay? So the first thing we look at, alright, y equals e to the x. Alright, so you're going to put the dx of e to the x is equal to. Alright? Anyone want to take a wild guess at what the derivative of e to the x is? No. What do you say? Is what? Yes, the derivative is e to the x power. Alright, so the derivative of e to the x is e to the x.
You want to explain why?
Why? Well, because what we can do is we could go through and sketch this around. Alright? So if we want to sketch the derivative of this, we know that the derivative is the slope of this, all these ones, right? Right. So right here, this derivative, as we get further and further out here, the slope of this is getting closer and closer to zero. Right? So it's getting flatter and flatter. Well, so this is getting really close to zero out here. This is getting closer to zero. Right about here, that looks like, it looks like if I were to sort of continue from here to there, that looks like that, that looks like a pretty decent estimate of that slope right there. So right there, that slope would be, so that would be up 1 over. So the slope of that would be 1. Alright, then, see, it looks like right here, the slope right about here, that kind of looks like it'd be slope of 2. So, right there, you have slope of 2. So, it's just going to keep increasing. Further out we go, higher it's going to get. Essentially looks like the same graph, doesn't it?
Oh, yeah.
I will prove it to you. Because the calculator's out there that can graph this. So, we go over here and look at Desmos. Maybe. There's the graph of e to the x. Alright? Watch this. The derivative of e to the x. Oh, it looks about the same, doesn't it? Are you pretty confident that the calculator is telling us that it's the same? Yeah. So, it appears to be e to the x. Thank you for the graph. It is e to the x. Now we need to sort of, we're not going to examine that in our calculator. Alright? So what we're going to do is this. We have to include it in the chain rule because, okay, so e to the 2x. Okay, guys, the derivative of e to the x power is e to the x. So instinctively, what you might be tempted to say is that the derivative of e to the 2x is e to the 2x. Not, because this has chain rule. Right? So you have e to the 2x, and the derivative of that would be e to the 2x times what would be this chain rule part that we're looking at? 2x, what's the derivative of 2x? 2. So the derivative of e to the 2x would be equal to 2e to the 2x. So what we do is it's going to be equal to the derivative of u times e to the u power. And it'll make sense if I show it to you. So it's saying let u be a function. Right? 5x plus 2, 9x. So the derivative of this is equal to e to the u times du.
Oh. Okay.
They'll make a lot of sense when you see the example. Okay, so e to the u times du. So you always have to, now that we know that the chain rule exists, we always have to make sure we're including that in there. So let's look at some examples. Y equals e to the x cubed power. So we're looking at this one right here. Y equals e to the x cubed power. So dy dx will be equal to, all right, e to the u. So this is going to be e to the x cubed power times the derivative of u. What's the derivative of x cubed? The x squared. So all we have to do is, rewrite this a little nicer. 3x squared times e to the x cubed power. That is our derivative.
You were very lucky to be here.
Totally.
I went to conference there.
I'm gonna get questions about that one?
Hold on, Bob, just fill them out.
Just because I like, yeah. Do my phone. I'm sorry that if you saw that noticing card result, like, is it so it happened one night, I got some other places. Alright, let's look at this problem. Alright? So, we have, I want to find dy dx. You start from the outside in. We go from the outside in, work our way in. So, what's on the outside? So, it's going to be cosine of e to the x squared times, and take the derivative of e to the x squared. So, what's the derivative of e to the x squared?
To the end.
Well, hold on. It's gonna be, just think of the way it's supposed to, you can rewrite stuff like
Oh, no, back on.
e to the x squared power. It's gonna be e to the u, so e to the x squared times the derivative of our x power. So the derivative of x squared is what? 2x. So our answer is 2x times e to the x squared times cosine e to the x squared. Makes sense? Makes sense? Alright, so the next one is the product rule, right? It's going to be dy dx, product rule. So this is u, and that's v. So it's going to be u times dv. So it's going to be e to the 4 minus x power times, what is the derivative of 4 minus x? Correct. Alright, plus v times du. What's the derivative of u? 1. So our answer is, and then negative out front with negative x e to the 4 minus x plus e to the 4 minus x. Questions about that? Oh, Alright, right here. We have one last problem with e to the x, with exponentials. So we have dy dx is equal to, this is u and v. Okay? So, this is what rule in here? Quotient rule. So it's going to be v du. So it's going to be times e to the sine x times, what's the derivative of sine x?
Cosine.
Cosine x. Does that make sense how we got that?
So we got that from the side effect.
Yeah, so that e to the sine x times cosine x is the derivative of u. It's going to be e to the x one times the derivative of the x one.
Right there. Wait.
V times
Oh, okay.
du.
Oh, yes, it is, never mind.
E to the sine x times the derivative of x one.
I think never mind.
So then we have minus v, or minus u times dv, because the derivative of v to the x is to the x. Divided by dx squared. To simplify the way that looks a little bit, that'd be equal to, I have e to the x and e to the x. I can pull those out. Actually, I can pull out e sine x, e to the x. E to the sine x here, e to the sine x here, e to the x here, e to the x here. And pull out that whole thing, so it'll be, pull out e to the x e to the sine x times the cosine x left over minus 1 divided by divided factor e to the sine x and e to the x out of there. Then the only thing that I can do there is simplify that a little bit more. E to the x cancels out with this e to the x, so I'm left with one more e to the x on the bottom. This will be e to the sine x times cosine x minus 1 divided by e to the x. Questions about that?
No.
This one. It's easy. Easy. First thing jump over here. So the derivative of the natural log of u, okay, can be equal to 1 over u times du. 1 over u times du.
Do you know why,
Alright, so let's look at this. Here we go. Let's try to do some of these. So the derivative of this, so dy dx is equal to natural log of 3x. So the natural log of 3x, the derivative of that is going to be 1 over what's on the inside, so 1 over 3x times the derivative of 3x. So the derivative of 3x is equal to what? 3. That's equal to 1 over x. Yes? Alright. So that's good. Look, you're gonna look at this one. So y equals the natural log of 4x squared plus 3x. So it's gonna be
1 over
1 over 1.
4x squared times
Times the derivative of that. So what's the derivative of 4x squared plus 3x? 8x plus 3. So our answer is 8x plus 3 divided by 4x squared plus 3x. Pretty neat. You don't like that one? Alright, you ready? These ones? So, dy dx. So, the derivative of a natural log is 1 over whatever you're taking the natural log of. So it's going to be 1 over sine pi x times the derivative of whatever you're taking the natural log of. So it's going to be times the cosine pi x times pi. So now we got that. So simplify that, that'd be pi times cosine pi x divided by sine x. We need to look at this next one.
yeah.
So we have what rule does this have involved in it? Product rule. Alright. So it's going to be y dx that's equal to is going to be u of v. So u dv times 1 over negative x negative 1 plus v du. The derivative of tangent is squared. We have tangent x over negative x. Actually, negative tangent x. Negative sign there. Plus secant squared x times natural log of 8. Questions about that? Now that I did the initial one, this.